All right, everyone, welcome back to the AI Research Roundup. I'm your host, Alex. Today is May 6th, 2025, and we're looking at a survey paper that caught my eye on Hugging Face's trending list just 5 days ago. It's called 100 Days After DeepSeek-R1. This paper surveys studies trying to replicate the closed-source DeepSeek-R1 reasoning language model, or RLM, using open methods like Supervised Fine-Tuning, SFT, and reinforcement learning from Verifiable Rewards, RLVR. Okay, so moving on. This first figure really lays out the landscape. It gives us a taxonomy, a kind of map of the different training methods being explored to replicate those reasoning capabilities. You can see it breaks things down into the main approaches we mentioned: supervised fine-tuning, reinforcement learning from Verifiable Rewards, and then a category for other techniques like process reward models and preference optimization. It helps organize the different studies surveyed. Building on that taxonomy, this next section provides a helpful summary. It lists various replication projects showing the size of their supervised fine-tuning datasets and what kinds of tasks they cover, like math, coding, or other reasoning problems. You can see a real range in dataset sizes, from under 1,000 samples to over 1 million. This really emphasizes the point about careful SFT data curation being crucial for these replication efforts. Moving to the results, this table then details several specific replication projects, including the original DeepSeek-R1 for comparison. You can see the initial models they used, often variants of Qwen, and importantly, their scores on math benchmarks like AIME and Math 500. It gives a clearer picture of how close these open efforts are getting to the target performance using the methods we've discussed, like SFT and RLVR. Alright, so we saw how the models performed. Now, this table shifts focus specifically to the datasets powering the reinforcement learning from Verifiable Rewards, or RLVR, efforts. It lists numerous open-source datasets, like Math RLVR, DeepCoder, and others, showing their creators, sizes, and whether they target math, code, or general tasks. This really underscores the community's work in building the data resources essential for successful RLVR training. Following up on those RLVR datasets, this next table digs into the how, specifically the algorithm selection and reward design for these open-source replication studies. It lists models alongside their initial checkpoints, the specific RL algorithm used, like PPO, GRPO, and several variants, and the reward signals, which predominantly feature accuracy, sometimes combined with format or length. This gives us a practical look at the RLVR implementation choices researchers are making. Okay, so after looking at the RLVR algorithms and rewards, this table really brings it home by showing the performance results on math reasoning tasks. It lists various open-source replication models, their initial checkpoints, and crucially, their scores on benchmarks like AIME and Math 500, comparing them to DeepSeek-R1. This quantifies how effective those RLVR techniques are in practice and how far the open efforts have progressed towards the target. So to wrap things up, it's clear the community is making really impressive strides in replicating sophisticated reasoning models using open methods like SFT and RLVR. Careful data curation and smart algorithm design are absolutely key here. Well, that's all for this AI Research Roundup. Thanks for tuning in, and I'm Alex, signing off.